There we go. How's it going there, JB?
Hey folks, good how you doing?
Oh, we're doing great. So, we're going to be talking about game development. So, when I hear game development in C Sharp, I immediately go to Unity,
Yes, we'll be talking about the Unity, but not only. Uh,
but
let's
not
get
only
started.
Unity. All right. All right. You've got me intrigued. Let me bring on your slides here and I will hand over the conference to you. Take it away, JB.
Thank you. So, hi everyone. Thank you for joining me live for the penultimate session of .NET Conf. My name is JB. I'm an engineering manager at Microsoft on the Visual Studio team. My focus right now is to make sure that game developers are successful and productive with our family of developer tools, with a special focus on Visual Studio and .NET. And today we'll be talking about exactly this. Uh, for many people, when they think about .NET, they don't necessarily think about game development. And yeah, C Sharp and .NET are used all throughout the game development industry. If you played a game recently, especially on mobile, there's a good chance it's been running some C Sharp code, and there's an even bigger chance that this game has been built with tools created with C Sharp and .NET. And today I want to focus on helping C Sharp developers get started building games. I think, like many people, I started programming because I was interested in creating video games at a young age. I did not make a career out of creating video games, but I get to build tools for people building video games. So close enough. Uh, so let's get so let's get started. I have a few pictures of games that have been created with C Sharp and .NET. But let's focus and let's start with Unity. So if you've been living under a rock for the past 10 years, Unity has taken the world of game development by storm. I think Unity estimates that almost half of all games made today are made with Unity. If you played a mobile game recently, there's a very high chance it's been built with Unity. But what is Unity? Unity started as a tool to create 2D and 3D games almost 20 years ago, and it evolved into so much more. Today, you can create all kind of real-time experiences with Unity for all kind of scenarios. But today, for this session, we'll be focusing on game. Unity is a commercial product by our partners at Unity Technologies, and it has a free license that allows individual and small teams to get started before they bring any revenue. But more than that, Unity is an entire ecosystem to create your game. Um, Unity has an asset store online where you can acquire either paid or free assets, all kind of assets to create your games, 3D models, textures, sounds, entire templates for your game, which is very helpful if, like me, and you'll see about it later on, you're not really an artist. It can really help you build games that look fantastic simply by getting assets from the store. Unity has a huge learning section online where you can learn all about creating Unity experiences. And Unity also has a bunch of services, CI/CD, crash reporting, source control. All of them are integrated into Unity. And again, Unity is that's a very like simple explanation, but Unity is so much more than that. And I think one of the biggest strengths of Unity today is all the platform it supports. Basically, if you want to create a game, Unity supports all the platforms that you could want to create a game for. Uh, yeah, let's start right away and start creating a Unity experience. So when you install Unity, either from the Unity website or from the Visual Studio installer, which has a dedicated Unity workload where from the Visual Installer you can download everything that you need to build games with Unity and Visual Studio. That is going to install something called the Unity Hub for you. The hub is your entry point for Unity, and that's where you manage your different side-by-side Unity versions if you're maintaining a bunch of them, and all your Unity projects. And that's where you create new projects. And you have all sort of templates, 2D, 3D games for mobile, for VR, for AR, first-person games, third-person games, and even full-blown games that you can use to learn or to better create Unity games. I've created, and today we'll start with an even more a completely bare project so that we can learn the very basics of Unity and how easy it is to get started. So this is the Unity editor. This is your main environment from which you'll be creating a game. You have your scene view, the hierarchy of all the objects in your scene, and all the assets as files in your project. Well, let's get started building a small game. I'm going to create a 3D object, a plane. Let's make it 10 by 10. Let's create a new material. Let's call it ground. So that's our ground material. Let's pick a color, a light brown. Let's make that, and we already have a ground. All right, let's continue adding things. Let's add a cube. All right, let's make it 4. And it might not look like it, but you'll see I'll be creating a tree. Let's create a new material. Let's call it trunk. Let's make it brown. Like a darker shade of brown. Yep. All right. And let's create a new cube. You'll see I'm very much into cubes. Let's make it slightly bigger. Let's create a new material. Well, let's make it a nice shade of green. All right. So that's the trunk. That's the leaves. Let's reparent those two objects into a tree. Let's give a tree a rigid body. And then we can take this tree and put it back into our assets. And now, well, now we can create more trees. Put it all throughout our scene. That's pretty easy. So that's currently what we're seeing. So now what I'd like to do is to be able to, well, move through those trees. Let's create, and for that we need to create some behavior. So let's create a new script. Let's call it camera movement. I double click on the script that's going to open Visual Studio for me, 17.4, which just got released. Let me get my snippets. All right, so what's happening here? We have a camera movement type, which is going to be instantiated by the Unity engine and attached to my camera. Update is a special Unity function or method. That's why it's painted differently. And it's going to be called every frame. And what we're doing here is very simple. Every frame we're going to check if we're pressing right, left arrow, or up. And well, we'll move the camera accordingly. So let's add our camera movement script to the camera. Play the game. And now I can move in my scene. But you can also create things dynamically. So let's go back to the scene. Let's create a new script. Sorry, let's create a new cube again. See that I'm very much into cubes. Let's make it slightly smaller. 0.2, 0.2, 0.2. Let's create a new material. Let's call it bullet. Let's make those a nice shade of red. Let's call that a bullet. Let's give that a rigid body. And now I'm going to take that bulletin, move it back to my assets folder, and create a prefab out of it. I don't need this one anymore. And I would like to be able to shoot bullets. So for that, I'm going to create out of my camera. Why not? So I'm going to create a new script. Shoot bullet. Open it in Visual Studio. It from my snippets. So what's going on here? We have a shoot bullet type, again, which is going to be instantiated by the Unity game engine and attached to my camera. It exposes two fields, one prefab that we want to instantiate and a speed. And every frame, we're going to check if we press the space key. If that's the case, we're going to instantiate a prefab and give it a speed, velocity. Let's go back to my sample. Let's add our new shoot bullet script to our camera. We can drag and drop the bullets prefab. As you can see, all the fields that are public are exposed in the inspector so that you can tweak things from the editor and not from the code, which is very convenient for designers. I run the game. I can shoot my bullets and navigate in my scene with my beautiful trees. And well, because all of this is dynamic, if you're not into shooting bullets, well, maybe you can shoot trees. Yep. Easy, no? See? In just a few minutes and a few lines of code, I almost created Minecraft. So that's pretty cool. And well, if you're slightly more talented than I am, this is what you can create with Unity. That is the 3D Game Kit, which is a sample that Unity publishes on the Unity Asset Store. And well, it looks like an actual, beautiful, and real game. I don't know if you have the sound, but yeah. That's what you can create with Unity, and that is a very, very, very fast and small way to check it out. I would like to talk so because this is .NET Conf, let's talk a little bit more, where are my slides, about Unity's .NET support. Today, Unity, the game engine, embeds Mono to run .NET code. This Mono supports a .NET 4.7.1 .NET Framework profile, but it also supports, and it's a custom profile because it supports an addition, which is the APIs from the .NET Stellar 2.1, which means that you can build Unity experiences, program with C# and still use the fast span APIs that came with the .NET Stellar 2.1. Unity comes with a C#9 compiler, and for .NET developers, one of the things that is probably the most surprising when they learn about Unity is that Unity's build pipeline is completely custom. It doesn't use MS Build. It doesn't use Visual Studio Project. It doesn't use NuGet. It uses its own custom package system because Unity needs more than code into packages, but you can also package all kind of facets. So there is a little bit of a learning curve for .NET and C# developers when they go into Unity. But on the bright side, Unity is moving to the modern .NET ecosystem. They've announced that they're going to adopt MS Build. They're going to make it easy to access NuGet in the future. And Josh from Unity is going to talk all about it in the next session. One word around the Visual Studio tools for Unity. So this is something that my team is doing. And our goal is basically to provide a first-class experience to build Unity experiences with Visual Studio. As I said in the beginning, there is a dedicated workload in the Visual Studio installer. In just one click from the installer, you can install everything that you need to build Unity experiences with Visual Studio. And we ship with a bunch of dedicated productivity features that are specific to Unity. And we work behind the scene to make a seamless experience building Unity games with Visual Studio. So if you look at the code, as I was saying, you can see that update is painted differently to special Unity function. You just need to know them, but we do provide code completion for them. Debugging is very simple. You just put a breakpoint, you press F5, the debugger attaches. The first time you attach a debugger, Unity is going to recompile and reload the code in debug mode. So let's go ahead and do that. Taking a little bit of time. Let's play the game. So now if I shoot a bullet, my breakpoint hit, I can step. We have dedicated extension into our debugger. You can see the active scene. You can see all the game objects in your scene. You can step. Everything works as expected. So this is really cool. All right. Let's touch debugger. One thing that I would like to talk about is our open source project, Microsoft Unity Analyzers, which is a collection of Roslyn Analyzer. Roslyn is our compiler infrastructure that comes with Visual Studio and .NET, and it allows us to create warnings, errors, and suggestions that are completely tailored to the Unity API. So for instance, in that case, we have a suggestion telling us to remove the empty Unity start message, because otherwise Unity is going to call it, which is unnecessary. Another example would be right here. We have a vector, we're multiplying it by a float and another float, which means that this is going to be converted to a vector and multiplied by this one. And it would be more efficient to multiply the two floats together before converting it to a vector. And we do have an analyzer and a code fix that suggests to do exactly that. So we have around 50 of those analyzers that are guiding you to make sure that you're using the Unity API as efficiently as possible. And it's open source, so you can submit ideas or contribute analyzers on GitHub, which is really cool. So this was a very fast and simple overview of Unity, but Unity is not the only way to create games with C# and .NET. I'm going to talk a little bit about Godot. I think no one is really sure how to pronounce Godot or as a project. I'm going to trust my French and just pronounce it Godot. So what is Godot? Godot is a free and open source project. Just like Unity, it's an editor-driven workflow. It's very easy to acquire. You go to the Godot website or to GitHub. You download it, you launch it. You don't need it. There's not even an installer. It's very easy to get started, and it's been actually incredible to witness Godot's growth and all the work that is being put into it. So it really is a very interesting project to watch. You can build games with Godot for all the major platforms: Windows, UWP, macOS, Linux, iOS, and Android for mobiles. You can export for the web through HTML5 and WebAssembly. And you can even export to console through third-party providers if you have Godot games that you want to ship on consoles. Today, the stable version of Godot is Godot 3, and it ships with, like Unity, with Mono, and you can use that to build desktop, mobile, and web games. What I think is very exciting is that they just shipped the beta 4 of Godot 4, which completely swapped the scripting engine underneath and now uses .NET 6. So it comes with C# 10, and they're using that opportunity to leverage all the performance improvements and features that came with .NET 6. A big one is Godot being able to move from their reflection-based integration to source generators for better performance. And today, if you're using the beta of Godot 4, the .NET support currently only works on desktop platforms. So let me show you Godot. As you can see, it's very similar to Unity in spirit. You have your scene view, your hierarchy into scene, all your files. I made a very simple game, which was again a cube in front of a camera, and I'm simply rotating this cube. So if I look at the code, again, it's very similar in spirit to Unity. You have a class that is attached to your game object, and methods that are called by the Godot engine. And every frame, we're going to rotate the cube. The great thing, as I was saying about it, is that because it's built with .NET 6, you have access to the entire .NET ecosystem, including NuGet. So here I'm putting a NuGet for my own open source library, which is called Cecil, which is a .NET binary reader and writer. So if you want to create an OR game about .NET metadata or an IL bytecode, well, you can do it. In this case, I will simply be randomly displaying all the IL opcodes in my game window, which is good enough for a OR game, but it just works. So yeah, again, Godot, very interesting open source project. I hope you check it out. I have 5 more minutes, and I'm going to use them to talk a little bit about Monogame. Um, so Monogame has been used to create games that have been very successful. You might recognize some of them. Monogame is free and open source, hosted on GitHub. It's a re-implementation of an old Microsoft framework named XNA that was before my time. You can create games with Monogame for multiple platforms: Windows, UWP, macOS, Linux, iOS, and Android, HTML5 through WebAssembly, using the .NET export, basically using .NET for those platforms. And they also support console if you're a console partner developer. What I really love about Monogame is that it's a code-driven workflow. So you basically add an extension to Visual Studio, the Monogame extension through the extension window. It's going to add a set of templates to Visual Studio. You use it to create a new game, and that's what I have here. The main is basically using game, new game, and game run, which is as simple as it gets. And the game is, again, a type with a constructor, an initialize method where we're load content, where we're loading content. In my case, a texture with a square, because I love squares and cubes. And did you know that Visual Studio comes with an image editor? That's pretty cool. Every frame, Monogame is going to call the update method too, where it's basically where you change the state of your game, and then you're going to be called to draw your game, and that's where you'll draw your game. And in this case, it's a very simple game where I press Ctrl 5, I launch my game, and I simply move a cube, well, a square, my green square. Let's make it more friendly. Here you go. Control S, Control 5. And the nice thing about it is that because it's all .NET 6 and Visual Studio, well, you can go change the speed, for instance, do hot reload, and you're hot reloading your game, which is pretty cool. Oh, and you can change the background of your game with just the press of a touch. I know I'm a great game designer, but if you have a little bit more time and skills than I have, well, that's one of these samples of Monogame. Well, that's Monogame. And yeah, and that's all I have today. Again, as you can see, there are multiple tools or products that you can use to create games. It's never been easier to get started creating games with C# and .NET, and I'm looking forward to, well, all the games that you're going to create, and let me know on Twitter. Thank you, folks.
There we go. Oh my gosh, I had a problem getting the thing to click right there. JB, I love seeing all the cool stuff around Unity and how easy it is to get started. If only I was that artistic that I could make trees that fall over so quickly. My goodness.
I know, but again, Unity, Godot, so Unity has the asset store. Godot has sort of an equivalent where they have templates and things that you can use. So if you're like me, not very talented with artistic skills, fortunately, plenty of people are, and they're making assets either paid or free that you can use.
Very good point, right? Bring those in, and you can get started and build something cool very quickly.
Yep.
Awesome.